we were actually able to go back to the practice, get them to research, and they found us the X-rays that are listed there. Those are an OPG and some bite wings. This is the OPG that we got. Now that OPG is several years old, it's 6 years old, and you'll notice that the only restorations that are visible on it are 2 pit amalgam restorations in tooth 1-6. So, we have our post-mortem data set. Now we ask our radiographers to produce comparable images. So we've scanned the bottom jaw and the top jaw separately, and you can see that those images look similar to, but not identical to, APGs. But if you look at tooth 1-6, you'll notice that the amalgam restorations are not visible. What we have been able then to do is to ask the radiographers to go back and now do an occlusal reconstruction of the upper jaw. And when we do that, those fillings that are present on the OPG but are invisible on the MPR now become visible to us, and they're highlighted by the yellow arrows. So we are able to identify the presence of those fillings. Because of the match, and I'll just return, I'll go back one, because of the similarity between the positions and the morphologies of all of the teeth and their distribution between both the MPR and the OPG, as well as the presence of the 2 pit amalgams, we are able to establish an identity of this body. And there you can see the similarity in root positions, morphologies, pulp shapes between the OPG and the MPR of the mandible. So our finding in this case is going to be identity confirmed. But notice, we have never actually come in contact with the deceased. All of this can be done from our office, or indeed from home. Case 2 is slightly different. This record comes from the information system from Oral Health and Queensland Health. As you can see, it is terrible. This is the data that we get from a public health clinic. It does not record images, but we can find a number of things from it. If you have a look at the blue arrows, they indicate the teeth that are missing. The red arrows indicate that we have a couple of restorations. Green arrows, we're not going to refer to them at this stage, except that once again they refer to some restorations. But let's now have a look at our image. So we can straight away see that all of the upper teeth are missing in the dental record. All of the upper teeth are missing in the MPR. We can also look at missing teeth on the lower jaw. Look at the blue arrows to indicate the translation. The red arrows indicate corresponding dental restorations. However, the ISO records are not complete, and in some respects they're actually wrong. They do not record all of the teeth. So at the end of the day, the green arrows tell us about the extensive tooth destruction that have happened since the ISO records were gained. And this is pretty consistent with someone who's a methamphetamine addict. So while we've got a lot of similarities, at this stage, we're really only dealing with very sketchy notes versus a lot of destruction in a mouth. So we will say that there is a possible identification. We can't exclude this, but we will always choose the most conservative option. If ever there's doubt, we will choose the most conservative possible outcome. And in this case, this is not an exclusion, but it's not an identification. In other words, they need to find another modality, which in our case is likely to be DNA, because this body was badly putrefied and fingerprints could not be obtained. Case 3 illustrates a different opportunity. In this case, we have extensive treatment notes for the patient, but once again, while these notes record basic information, they do not record that any images have been available. They do, however, mention that in the upper jaw there's going to be a cast metal denture. So now we have to become detectives, and we will comb medical radiology databases to see if we can find an image for this patient. And lo and behold, we were able to do that. Mind you, the image is 13 years old. We also have, from 2017, an X-ray report with no images. The X-ray report is listed there. It gives us basically zero information. However, if you have a look in the lower left premolar region, you'll note that there are two pieces of amalgam that are now present in the bone and represent two very small radio opacities. Can you all see those? Okay, they are going to be unique. So, if we get our MPR, it shows the presence of a chrome denture in the upper jaw, and once again we can see those two amalgam artifacts in the mandibular bone. On the basis that all of the other root anatomy and the presence of fillings matches, we're able to move this to a conclusive identification. Once again, never having left our office. All of this is done within a time frame of about 2 hours. Now, the last case is one where we've got an MPR. The only X-ray that we've got is a PA X-ray. But now we're able to superimpose that PA X-ray over the CT reconstruction. And now you'll note that we get an almost perfect correspondence. So once again, we move to identification without ever having seen the body. Our imaging is generally done with Adobe Photoshop, which many of you will be familiar with. That is our primary tool for identification work. We never manipulate the images in any way other than that if we have a high-resolution image and a low-resolution image, we will reduce the resolution of the high-resolution image to match that of the lower-resolution image. Otherwise, there is no manipulation done. So our conclusions are these. Post-mortem CT data, if it's available, can be very helpful in determining questions of identity. Certainly, around Australia, it can be obtained as soon as the body is admitted to the mortuary. So the moment we'll turn up for work, the data will already be there. We do not attempt to either secure the CT data or to slice it ourselves. A very competent radiographer is the best thing you can have to aid you in this work. So we say an experienced forensic radiographer is an essential part of the workflow. We can compare the images that they produce with dental treatment and dental images. The most important thing, though, is this. That CT data can come from anywhere in the country where there is a CT. We no longer have to travel large distances to do identifications, and that means we no longer deprive Brisbane of a treatment facility when we leave. So if you are dealing with something like Indonesia, where you have an absolutely massive archipelago with huge distances, something like this may make your work very, very much easier. And as we look to the future, I would ask you to keep this in mind. Wherever there is a CT scanner, and the body does not need to be removed from the body bag to be scanned, post-mortem data will be available. So distance is no longer a consideration either for travel or for speed of response. If you have post-mortem CT as well as ante-mortem CT, then you have an even better option for identification. But I haven't illustrated that in this presentation. So, once again, I return to what I said yesterday with the future. CT can also be used to develop three-dimensional models of teeth. And together with either an ante-mortem CT or an intraoral scanner, don't forget that the future involves the third dimension, when we can actually do three-dimensional superimpositions in order to secure an identity. So CT, incredibly valuable stuff. And I'm sure that Rizky will now move on and show us how CT can also be used for age estimation. Thank you very much.
Thank you very much for your insightful presentation, Professor. Now we move to the second speaker after Professor Forrest talk about the CT data for forensic odontology identification. Our second speaker will talk about one variant of CT. As we know, CBCT or cone beam computed tomography is the other kinds of CT scan or medical CT, but in the cone beam shape of X-ray source. So the second speaker will talk about the use of CBCT in one of branch in forensic odontology is dental age estimation. So I will read the curriculum vitae for the second speaker. Our second speaker is Dr. Gigi Rizky Merdietio Budi, Master of Forensic Odontology from KU Leuven, Belgium. And now he is PhD candidate in forensic odontology at the University of Dundee, Scotland. There are so many research and publication that he worked, and the latest is in the Journal of Forensic and Legal Medicine, his systematic review and meta-analysis entitled The Radiographic Diversity of Dental Patterns for Human Identification. Dr. Rizky is a graduate from Universitas Airlangga in 2016, and he got his master degree in 2018 in KU Leuven, Belgium, and now he is ongoing PhD in, there are any wrong in here. He is ongoing PhD in University of Dundee, Scotland, and his contribution in many disaster victim identification team, and the latest in the Tangerang prison fire in Jakarta. So I would like to invite our second speaker. Please, Dr. Rizky, take your place here. Please welcome Dr. Rizky Merdietio Budi. Dr. Rizky also the assistant professor or lecturer in the Universitas Diponegoro Semarang in Division of Forensic and Medical Legal from Faculty of Medicine. So, Dr. Rizky, the time is yours.
Thank you, Doc. Morning, everyone. I'm Rizky. Saya Rizky. I'm currently a student in University of Dundee, Scotland. It's a long way here. I think I took the flight about 20 hours, something. I don't know. I even forgot that I am on a plane. But let's go on, please. Yes, so we will talk about the usage in dental estimation, especially for CBCT, and especially again in adults. But in this presentation, I will maybe speak most of it in English, and sometimes I will speak in Indonesian, so please do excuse me. Yeah, so what will you get in this? What's the content of this presentation is? So I will give you the basics, mostly in dental age estimation, and how we do incorporate CBCT in dental age estimation. And lastly, we in the University of Dundee develops multiple methodology, multiple statistical approach for our newest method. Yeah, so first, we will talk first about the concept. So I want everyone here to have the same introduction to dental age estimation, even though I knew that some of you already have the experience of it. When I'm doing a literature research for my dissertation, I found this sentence. This is the earliest sentence that I found for dental age estimation. If you can see, it is really wrong. So what the sentence said is, in the 7th month, the upper tooth will erupt first. But we know now that that's nonsense. Jadi itu salah harusnya. Itu harusnya salah. Jadi kira-kira ini tahun berapa sih? Ada yang mau menebak mungkin ini tahun berapa? Can you guess what year is this literature? I remember that in my bachelor year, I think my professor is here. Professor Mika is here. She is my teacher. Professor Mika always told me that I need to use early literature, latest literature. But I'm sorry, Professor Mika, but this is from 77 years before Christ. So I don't know what do the guys do then. Like, they just see a tooth and they write it, I don't know. But this is the earliest literature that I can find for dental age estimation. Well, at least that's right. And what's the scientific basis for dental age estimation? We humans changes throughout our lifetime. Whether it is we are progressing over something or we are regressing over something. Jadi kita berkembang dan kita akan menyusut. Dan gigi kita juga seperti itu. Our dental is like that. If I can give you an example here, there is, how do I use the pointer? So in the left side, it's the progressive change of our tooth, and in the right side, the example of how our tooth is regressing over time. It's either attrition or root resorption, anything. And there are multiple factors influencing these changes, whether it's internal or external. There is so many factors that we met in an intersection. Jadi umur kita tuh selalu bertambah. Pasti besok kita pasti akan bertambah umurnya, tapi gigi kita kadang-kadang agak ragu-ragu. Uncertainty of other factors. Jadi kalau saya boleh bilang, kita menebak. We are guessing a constant variable from an ever-changing variable. We are guessing something that is constant for something that is not constant. That's the game of dental age estimation, and we need to find the middle way. So, well, this is some sort of definition that I can found. So it's just to estimate. The key word is to estimate a chronological age. I understand that age maybe there is multiple age definition, but if I say age in this presentation, I will mean that it's chronological age, just to save time. Jadi umurnya, kalau saya bilang umur, ya pokoknya umur lah. And I know that there is a difference between variable and parameters. We will just put that out. Jadi kalau saya ngomong variabel, parameter, dianggap aja sama. Saya tahu ada bedanya, tapi anggap aja sama. Nah, kenapa kita sebut ini sebagai estimasi. Why is it we call it estimation? Well, because it's just an educated guess. We are just guessing. Kita cuma nebak aja, tapi kita agak mikir, nggak asal tebak. Jadi kita yakin bahwa kita besok pasti satu hari lebih tua, tapi kita juga tidak yakin apakah kita akan punya atrisi 1 mikro. So that's the constant part is the days of we are becoming older, and the inconsistent part is our, well, in this case, our attrition. Therefore, it's not really a pinpoint accuracy. If you give us, if you give a dental age estimation results, it needs to have an error because you cannot guess the exact point because we are just guessing. This is just an educated guess. So why we do this? It's to understand the progressive and regressive changes. It's useful for orthodontics, I think. Yeah, orthodontics. And in identification manners, we can close down an antemortem data pool. Let's say that we have 10 people. In our antemortem data set, we have 10 people, and only 2 of them is below 18 years old. Jadi cuma ada 2 yang di bawah 18 tahun. If we done the dental age estimation, we can focus on that 2 people if we found that someone is on that range of age. Yeah, normally if we do age estimation for linear one, we will do it in the form of regression. And the second one is if we have some legal conducts. Let's say that we don't know if someone is above or below 18 years old for them in the legal justice system. So we need to know whether the person is above 18 or below 18. In that part, we do a logistic regression. And don't mix them. Don't mix them. Don't predict someone above or below something using the linear regression, and don't do linear regression on legal age. That doesn't mix. It just doesn't right. This is the definition. The definition of age in dental age estimation is kind of weird. Like they say that you are an adult if you are above 24 years old. But that's what my professor said in KU11, so I just eat it. Jadi kalau di dental age estimation 0 sampai 16 itu anak-anak. 16 sampai 24 itu remaja, 24 ke atas itu dewasa. Kenapa seperti itu? Nggak tahu, tanya yang bikin tesis. Lanjut. Now we are focusing more in dental age estimation for adults. The difference in adults is that we don't have anything that is growing. And the growth is the most, well, not most, it's the most constant changes in our life, the growth. It's easier to predict. But in adults, we have, well, according to Gustafsson, we have these 6 main parameters. Attrition, periodontal regression, secondary dentin, cemental apposition, root resorption, and translucency. This 6, as you can see, is really heavily influenced by external factors. Kayak bayangin aja atrisi itu kita bruxism aja udah berubah. Periodontal regression, misalkan diabetes sudah berubah lagi. Jadi ini sangat terpaku sama faktor-faktor eksternal. Karena kita punya banyak faktor eksternal, akhirnya error rate-nya makin tinggi. In adults, you cannot expect a lower error rate. It is never low. It's always high. It's almost 4, 6 years old. It's never low. This is the example of examining those 6 parameters. You can see the attrition in the left picture. You can see the attrition. You can see the secondary dentin. In the right, you can see the root translucency. And you can see the cementum apposition there. We can observe that in a clinical manner. But technology change. Technology change, and the more common the usage of dental age estimation, people start to realize. So from the 1950s to 1990s, people start to realize that they need something better than the invasive one. But in the invasive, they need to pull the teeth out. Sometimes they need to dissect it like this. This is the Gustafsson original method. And what's the limitation of the invasive approach? We need to destroy the teeth, obviously. And because we need to destroy the teeth, you cannot use it on the living population. Data granularity and model output. So, well, I am basically in data estimation, I have a lot of math. But in this presentation, I will try to push down the math a bit. I will not give you some numbers, random numbers. So yeah, the data granularity and model output. So let's say, let us see that the first 2 images on the left. The first one with no attrition. The second one with halfway through attrition. What if the attrition is in the middle of them? The data granularity is not really nice. Jadi kalau dia ada di antaranya 2 itu, terus mau apa? Nggak bisa kan? Akhirnya kita harus naik 1 atau turun 1. Jadi datanya itu tidak granular, tidak apa ya, tidak bersih gitulah. Karena kita harus mengalah. Inilah salah satu kelemahan dari invasive approach. Berkembang lagi ke non-invasive. We are progressing to a non-invasive approach. There is more problems because the regressive changes. If you do dental staging, the changes is massive. Like you can actually see the crown, you can actually see the root, you can actually see the root is closing. But in a non-invasive approach, you cannot see that. This is like some of the methods. Like if you can see that you need to be really, really detailed. Like you need to pull the line outside of the tooth. Everything needs to be pinpoint perfect for it to work. Especially with the Kefal method where you just have multiple calculation all over the place. But that's great, that's useful. At least we have some educated guess of what it is. Let's compare it. Let's compare it. The data on the non-invasive approach is more detailed, it's more granular, although that we don't really calculate all that much, but the data is more detailed. And we can see that in the previous image that mostly we use the 2D imaging, and there is multiple overlapping structure, and there is multiple distortions. Therefore, we want to eliminate that, and CBCT starts to become more common, and the possibility of gathering information, volumetric information. But you need to know that CBCT is not exactly 3D, it's just a 2D image stitched together to create a visualization of 3D. So it's not magic. It's not magic. Jadi CBCT itu sebenarnya cuma 2 dimensi, cuma dia ngambilnya 3 kali. 3 kali itu nanti dijadiin 1 sama dia. Nah, karena sudah dijadiin 1 sama CBCT-nya, seakan-akan kita punya visualisasi 3D. Jadi it's not magic. It's just a mathematical algorithm. So this volumetric information serves, maybe we can use it. Maybe we can use it. But from what I observe is if we have more information, we always have more problems. It's not the other way around. So we began our research. We are starting by the fundamental observation. If we read multiple publication in dental age estimation, especially in CBCT, and it's more common, they always gives us promise of, oh, this is better, this is always better, this is a high performance model, and so on. There is always that promise. Everyone have that promise. But we, as a forensics odontologist, we are really skeptics. We don't really trust them. Kita nggak terlalu percayalah, iya emangnya ya. Emang iya, emang benar-benar bagus. We need to answer it. So when I start my PhD, this is my question. Is it reproducible and reliable? Reproducible means that if I use it, you can use it too. Reliable means that if I have the model, you have a case, my model still can calculate that. Jadi kalau reproducible itu kita semua bisa pakai. Saya pakai, kamu pakai, kita semua pakai, prof dan dokter pakai, semua hasilnya sama. Kalau reliable, saya punya model, prof dan dokter punya kasus, model saya bisa dipakai. Reproducible and reliable. How do you answer it? We need to do a systematic review and meta-analysis. So, well, it's basically the same, but systematic review is gathering the information, meta-analysis is pulling everything into one consensus, one results. But I will not deal with the maths here. I will just give you the overall conclusion. So, in the systematic review, we can see that the first study, the first study that used CBCT is in 2006. So it's really new. It's just, what, 16, 17 years ago by Young et al. Mostly using volumetric. There is a few that still use metric. And there is a good correlation. It's great. It's great. Between the age and selector parameters, it is useful, good observer agreements, everything is nice. This is some of the examples of the methods. The left one, you can see that the authors is dividing the pulp chamber and the enamel. And the right one is using metric measurements, jadi cuma diukur aja lebarnya. Yang kiri sudah mulai pakai volumetric. And what's the meta-analysis said? There is a good correlation between variables and age. I forgot the number. I think it's 0.7, minus 0.7. Volumetric seems to be better. So volumetrics have better results to metric, but there is no significant difference. The next statement is a bit controversial, but that's what I found. It doesn't matter if you choose any tooth, if you do maxilla or mandible, if you do in any population, the results will still be the same. But at least that's my finding. My finding. Jadi mau nanti mau pakai gigi mana, mau pakai maxilla atau mandibula, mau pakai populasi mana, hasilnya segitu-segitu aja. Hasilnya tidak akan lebih dari saya lupa, di meta-analisis 0,7, nggak tahu lah, segitulah. Korelasinya pokoknya akan segitu-segitu aja. Okay, and then from that study, we see that we still have problems. There is a different age-related variable that is ignored. For what that is, I will explain in the next section. and they are always using a paid software. The software that they use is always fancy. It's always paid. It's like almost a couple of $1,000. So we need open source, so everyone can use it. Jadi kalau kita pakai software yang berbayar, itu memang hasilnya akan lebih bagus. Tapi percuma, kayak saya berbicara di sini menjelaskan metodenya bla 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 bla, ternyata pulang mau pakai softwarenya bayar. Ya, buat apa? So we need to develop it on an open source software. Now, second part is, yeah, we have modern problems and we will need a modern solution. First problem, software that is used is paid, selalu berbayar. And that is really limiting on the methodology reproducibility. So we propose a new standardized measurement in ITK-SNAP. ITK-SNAP is really light. You can use it anywhere. You can download it now for free. And this is what I found interesting. So in 1971, Johansson said that, in Johansson's research, he said that attrition, the first six, attrition, periodontal, etc., they have different correlation to age. Jadi 6 parameter atrisi dan lain-lain tadi itu punya korelasi yang berbeda sama usia. But I don't know why the modern research ignores that. I really don't know why. Everyone just ignores that. But thank God they ignore it, because if not, I will not have my PhD. So we propose a new method. This is the segmentation method. Jadi kita mau bagi. Bisa nggak kita bagi? In the software, it is a bit hard because the ITK-SNAP is free, so what do you expect? It's always leaking. So if you can observe that in the canine there, I try to measure the volume of the canine, it always leaks. I hate it. Kayak membersihkan bocor-bocornya itu bisa setengah jam sendiri, kadang-kadang bocor semua. But that's okay, it's free. Everyone can use it. So, but we have developed the new protocol that we need to intervene and we need to have the software automation at the same time. If we have it at the same time, it will be great. And we propose the segmentation. This is the cake. We separate between the root and the crown. We now have the volume of the crown, which is affected by attrition, secondary dentin formation, and we now have the volume of the root. Those two needs to be separated, well, in my opinion. Jadi kita pisahkan antara yang mahkota, karena mahkota kan kena atrisi dan secondary dentin, yang akar kita pisahkan juga, karena yang akar itu kena sama resolusi akar. So it should be make sense. So this is how it runs. First, we have the pulp, and we grow we check the crown. If you can see in the C, it's still separated. In D, we start building the root part, the lower root part, and it's finished. If we split them apart, it will look like in F. Jadi A, B, C, D, E, F ini semua satu kesatuan, yang di F itu cuma kita belah separuh aja untuk mendemonstrasikan bahwa di dalamnya ini nggak menyatu. Separasinya di situ. We separated in cemento-enamel junction. Well, the result is great. It's good. We have a good model performance. Maybe the error rate, I think it's about 6 years old, 5.8. I forgot. You can check it in my publication. There is no multicollinearity. What's multicollinearity? I will explain that later. 15 to 20 minutes per tooth. And the great part is, if you have a fractured tooth, Let's say you are in the DVI and you have a fractured tooth. As long as the CEJ is still visible, you can still calculate the age. Because we have separate them both. Jadi because they are independent from each other, you can calculate only the crown or only the root. Imagine. Jadi kalau misalkan kita dalam DVI, lalu kita menemui hanya mahkota saja atau akar saja, selama patahannya masih ada CEJ-nya, itu kita masih bisa hitung umurnya. Karena kedua variabel itu independen. Mereka tidak bergantung satu sama lain. And well, we are not really we are not easily to be satisfied. We still want more. So we start asking questions. In the previous one, as you can see that we are not separating the enamel. Well, we are not separating the enamel, but now we start asking questions, can the enamel be segmented too? We can separate the enamel. But first I will talk about it. I will talk about this in Indonesian, I'm sorry, because part of the this trip here is sponsored by University of Dundee. I need to talk about him, just to state thanks. Saya dari University of Dundee. University of Dundee itu ada di Scotland, ada di Skotlandia, ada di atas banget, sudah di separuh di atas, sudah nggak ada orang di sana hampir. Jadi kalau jaraknya, untuk sebagai bayangan, jaraknya London ke Dundee itu hampir sama kayak Jakarta Surabaya. Jadi kita di atas banget. Kira-kira seperti ini, katanya this is the city, this is the Tay Bridge, and that's the university. If you want to have a postgraduate course, kalau mau master di Dundee, ada dua, ada yang 1 tahun, ada yang 2 tahun. Kira-kira kalau mau untuk yang tahun ini, September, 15 Juli pendaftarannya terakhir. Butuh IELTS 6,5 sampai 7. Terus ijazah, teman-teman butuh dalam bahasa Inggris. Jadi kalau mau daftar, teman-teman butuh translate dulu kalau belum dalam bahasa Inggris. Kalau mau PhD, 3-4 tahun, harus dokter gigi dan harus punya master. Research, publication, thesis, boleh bertanya ke saya kalau mau PhD atau langsung ke program lead-nya, Dr. Sheila Manika, beliau baik banget, silahkan email aja kalau pengen tanya-tanya, pasti dijawab. Dr. Manika ini pembimbing utama saya dan pembimbing Zia yang juga alumni dari Dundee. Hai Zia. Terus, nah kalau ke sana ada Indonesian Society-nya. Jadi nggak usah takut. Kalau ke sana nggak akan sendiri, kita nggak akan membiarkan kalian hidup sendiri. Jadi teman-teman kalau mau ke Dundee ada Indonesian Society. Boleh follow kontak kita di Instagram atau email. So we'll make sure that you're not alone there. You know what to eat. You know what clothes to bring. We'll make sure to take care of you in Dundee. So back to the research. As we are not finding problems actually, we are creating problems. Kita sebagai researcher ini kadang-kadang nggak pernah menemukan masalah, tapi masalahnya kita cari-cari sendiri. More problem, more solutions. We found that the enamel can be segmented in CBCT. We are hoping by introducing new variables, we can improve the model predictive capability. But this needs to be remembered that the method is really, really difficult. but reproducible. I've done the reproducibility test with a colleague. She is a radiologist, oral radiologist, and it's still really hard. Like we have the reproducibility number like 0.7, it should be like 0.9. Jadi agak susah, biarpun sama teman saya yang FKG, ini pun agak sulit. But bear with me, it's okay. We separate them like this. We separate the pulp chamber first, and then we do the whole crown. After that, we separate the enamel. So we are not coloring it differently first. Jadi mahkota dulu full, baru kita pisah enamelnya. Itu ternyata cara yang paling gampang. Jangan langsung semua. Nah, itu pelajaran yang saya dapatkan setelah 2 minggu bertapa. Dipisah dulu. The model is way better. Like with just the crown, imagine if the crown is only like this small, and you can have a dental age estimation model that is only have a 6 years old error. Only from the crown, and there is no multicollinearity detected. But if you take a look at the minutes on how it's done, it's 25 to 30 minutes just to do one crown. It's really hard. And because the method is really hard, the reproducibility is really low. It's not low, it's still reproducible. This is the part that I cannot answer in my research. I don't know why is this happen. So if I invite you to my FIFA untuk sidang terbuka saya, in next July, please don't ask this because I cannot answer it. Jadi jangan tanya ini ya. I really don't know why is this happen. Like, if you want to answer this, I think you can get a PhD on your own. If you take a look at dentin to pulp, it's continually degrading. Like it's always reducing throughout our life. But why the enamel does that? So 20 to 40 years old, it's stagnant, and after that, until 50, it stops, and 50 to 60, it's gradual again. I don't know why that's happened. I tried to find in the literature, but I forgot that we actually find this first. So no one talks about it. And why does that happen? I don't know. Please, if you have some ideas, you want to do some research, you can answer that. I don't really want to see that picture anymore. Well, actually, we have another full methodology expansion, like a whole new one, but I will save it for later. Maybe, I hope in IFOS, if it is accepted, we can do it in IFOS. Yeah, so we have the full tooth segmentation, we have the crown, and now we can discuss some part. We can actually talk about something. And what we learn from the research. So from the systematic review, we can see that, yeah, CBCT can do dental age estimation nicely. And reproducibility is tied to observer experience and methods complexity. Those two is not separated. Those two is together. If you give an observer experience, a good experience of observer with the complex method, they still can do it. They will do it nicely. Because if we see a paper, if we see a research, they said, yeah, the method reproducibility is excellent. Yeah, you need to see that the persons that doing the methodology is oral radiologists with 20 years of experience. Of course, it's great. Come on. Jadi kalau kita lihat paper, kita lihat observer reproducibility-nya bagus. Kadang-kadang yang ngerjain itu RKG, SPRKG pengalaman sudah 20 tahun. Ya iyalah bagus, gimana sih? Kan pasti aja bagus. Coba kalau kita saya gitu yang ngerjain. Ya mungkin agak kalau jadi kadang-kadang hal-hal itu yang harus kita observasi. For the meta-analysis, I don't know if this is correct, but I think we are reaching a ceiling of predictive capability from regressive changes. It cannot be better. There is a certain limitation that it just stops. And we need a better approach for the statistical analysis. I will talk about this later again. It's just 2 or 3 slides more. And truth and population does not matter in statistical standpoint. So based on my views, it doesn't matter. It's just numbers, it's just different. It always be different. But in clinical application, it does. I believe it still does. So and from the segmentation approach means that if we want to have better results, the method will be harder. You cannot have a good results with easy method. It just doesn't make sense. And you will have a higher time consumption too. But it can be reduced maybe with the software development. The better the software, like the ITK snap stops leaking, it will be faster. Segmentation information can give you better representation of chronological age. And how many minutes do I have left? Okay, so cross-validation. We need to have a cross-validation in every research because it just gives you better model performance. So you cannot test a model on the same training set. Jadi, I will explain it in a lecturer term. So if you give the same exam and if you give the same problem to your students and the same problem you give them to their exam, they will have a good results, of course. Jadi kalau kita kasih soal yang sama ke mahasiswa kita, pasti kan ujiannya bagus. Nah, harus dipisah dong soalnya. Jadi, that's cross-validation. If you want to do a dental age estimation modeling, cross-validation. And there is also multicollinearity, which means that the information is given by the same variable. This needs to be addressed too. Like, you need to test the multicollinearity. Means it's the same variable, same information. It's just give you a somewhat bad results. And yeah, and there is still, and the last one is there is a trilemma in dental age estimation. These 3 factors will never match. You have time, reproducibility, reliability. Like, if you want to have a shorter analysis time, you need to choose if you want a lower reliability or a lower reproducibility. Jadi kalau misalkan kita lagi kerja, terus kita sedang dalam DVI gitu ya, ayo analisisnya harus cepat. Mau nggak akurat atau mau nggak reproducible, tinggal pilih salah satu. Nggak bisa kita punya tiga-tiganya. I will give you some example. This is my research in 2020. So we develop a fully automated staging. You give the computer the OPG and it will give you a stage. So the time really fast, 2 seconds, it will give you the whole stage. Reproducibility is excellent, but the reliability, the accuracy is just 54%. So it's bad. Next example, Tevison et al. Gives a Bayesian calculation. It's great to determine if someone is above 18 or below 18 years old. Time is short, of course, you just stage 1 tooth or 4 tooths, done. Reliability is excellent. He's even testing it on multiple population, it still does good. But come on, the reproducibility staging is okay, but the model is not. Imagine that if you are in a disaster, you are out in the sun photographing something, everything stinks, and you need to calculate this. Like, who wants to do that? No one. So the model reproducibility is not really that good. I can give you some more examples. This is from my research. I have some proving that some mathematical models will do better in third molar prediction, but you need to calculate this. If you want to do it by hand, yeah, you need to calculate this, all of this. So yeah, if you have something great, you need to remove something. Like if you want to have an accurate model, this is really accurate. This is an accurate model, but this is not reproducible. This is really not reproducible. You cannot actually use it without my calculation in the software. Yeah. So yeah, CBCT can bring a new expansion in dental age estimation. It's nice, it's good and all. And I think moving forward, we need to separate between the crown and the root. And yeah, complex and accurate methods does not mean that the method is better. So if we try to overcomplicate ourselves, well, maybe we get good results, but it's not really better. I think it's, yeah, thank you. That's the end.
Yeah, thank you very much, Dr. Rizky, for your interesting presentation about CBCT use in dental age estimation. As a radiologist, I'm very interested with your topic. Maybe in future days we can collaborate some research. Okay, we still have one speaker for this session, but because the Friday prayer is coming, so we ask for Dr. Fahmi your session after the Friday prayer. Thank you very much, Dr. Fahmi. So maybe I would like to invite again Professor Forrest and Dr. Rizky for Q&A session before we close this session for Friday prayer. Please, Dr. Rizky and Prof. Forrest, take your place. Maybe for the audience, okay, we will give the first opportunity for Prof. Mika. Maybe the committee, please bring the microphone for Prof. Mika. Okay, Prof. Mika, time is yours.
Thank you for the time. My question to Dr. Rizky, I'm proud of you because you are like my sons. Few years ago, my son in Erlangga University. So I will make a question for you, Dr. Rizky, about the method segmentation, ABC, from the crown. It is C and D, A, B, C. B and C is from labial and lingual. Oh, so it's better you because it's, and second statement is about your conclusion. Your result is now you not understand how like this result, but I think in the future will be many lecturers come to study more and more, and they can answer your question now. Thank you.
Thank you very much, Prof. Mika, for your question. Maybe Dr. Rizky, can you answer our teacher?
Thank you, Professor Mika. Thank you for proud of me. I'm really embarrassed. Yeah, in the picture, in the last picture, it's just being tilted. Jadi cuma diputar aja biar untuk memperlihatkan lebih jelas. From if you want to segment it well, it's 3D space. There is no up and down. Jadi mau pakai yang mana aja terserah, kan ini sudah 3D space, mau diputar-putar juga tidak masalah. So it doesn't matter. It doesn't matter if it goes upwards, inwards, in CT, everything is the same. Everything is a bit confusing. Yeah, thank you.
Yeah, thank you very much, Dr. Rizky. One question again for the audience, for Professor Alex Forrest or for Dr. Rizky. Okay, maybe I would like to ask. Oh, okay. Please, the Professor Hashimoto.
Dr. Rizky, thank you. Wonderful presentation. I would like you to teach me some, because my postgraduate student, he has the same topic and working for 1 year and nothing get, because he has no software for reconstructing three-dimensional model. He used a 3D bone, something like that. And he said the metal treatment material are very affected to get the image when he make three-dimensional tooth shape. So that's why he could not calculate the volume of enamel, volume of cementum, volume of tooth canal. So that is one he complained to me. I'm not sure. And also second one is it depends on the tomography, thickness of the tomography, right? So always he got the same CT image, cannot get the same image. Just all of them are different thickness of the tomography. So in that case, the volume are different, he said. So that's why not resulted yet for 1 year. So please, I would like you to recommend him to do this good images of the three-dimensional one. So you used the central incisor. My colleague, my student used the first or second premolar. So first molar usually treated with some metals. So that is affected to the 3D images. So you mean central incisor is the best for doing this research work, or you think is it possible to use premolar or molar for getting the age estimation? Please teach me. Thank you.
Thank you. Thank you, Professor Hashimoto. Dr. Rizky will answer the question from the Prof. Hashimoto or some suggestion.
Yeah. Thank you, Professor. So, for the CT, if there is a metal scatter, I think it will not work. Yeah, but please to keep in mind that I'm not a radiologist. I'm just a statistician, basically. But I should be working. But about the tooth itself, I think, based on my meta-analysis findings, it's just every tooth is the best tooth. They will do their own thing. And let's say that, so I calculate all the anterior tooth. Well, in the mass disaster, you can have all the anterior tooth. Let's say that we only have the premolars, the model can work. So, yeah, it's nice to have multiple tooth in our arsenal. It's like playing cards. You can, if you have multiple cards, you can play it nice. Right? So, yeah, there is not the best. Everything can be useful in dental age estimation. Thank you.
Yeah, thank you very much, because all the teeth maybe we can use for the dental age estimation. Yeah, but some literature say that our lecturer, Dr. Fahmi, is use canine for pulp volume estimation. Yeah, because some literature say the canine teeth is more strong and they can persistent in our dental arch longer than the other teeth. Okay, thank you very much, Dr. Rizky. And maybe the last question for Professor Alex, because Professor Alex Forrest talked about the postmortem CT data. How I would like to ask you about how do you think with the CBCT, because as we know CBCT is more widely used in dentistry than medical CT. So is it's the same, or any consideration that medical CT is more accurate than CBCT, or maybe any suggestion for you?
Sure, and thank you for the question. CBCT would, of course, be much preferable. But the problem is that mortuaries are not going to install CBCTs for us, so we're not going to get that post-mortem data. We can, however, on occasion get ante-mortem CBC data, which of course is fantastic. But again, we're still comparing it with PMCT. So until we can find a way of persuading our mortuaries that we need a CBCT, we're never going to get it.
Because maybe most of the CBCT machine have to make the patient with the standing position. Professor Alex, yeah. So, yeah, so we cannot use for the remain body.
There are actually models. There are actually models that you can use post-mortem, but you know, you're going to pay a lot for them. So yeah, conventional CBCT would be very difficult to use.
Okay, thank you very much for very insightful lecture from the Professor Alex and Dr. Rizky. They talk about how the advanced radiographic imaging for support the forensic odontology identification, because dental age estimation and how we identify the remain body of the disaster victim is very useful in forensic dentistry fields. So thank you very much, Professor Alex and Dr. Rizky, for your presentation. And now we move to the Master of Ceremony. Please applause for our presenter, Professor Alex Forrest and Dr. Rizky Merdiatio-Budi. For certification, please, Master of Ceremony, this is your time.
Thank you very much, our speaker, for the excellent and very insightful lecture. Next, we will attend our certificate admission to our speaker as a form to appreciate their willingness and their knowledge. The first certificate will be given to Professor Alex Forrest, MDSC, GCED, FICD, FPFA, FFOMP, RCPA, and Dr. Gigi Rizky Merdito-Budi, MF Odon. And we would like to invite Professor Hasanuddin to give the certificate. Ladies and gentlemen, our professor, Dr. and distinguished participant, thank you very much for your kind attention. Before we move to the next speaker, the participant can take a break for lunch and prayer. Please come back to the room at 13:15. Thank you very much. Mohon maaf, kami sampaikan untuk istirahat dan untuk sholatnya dapat dilakukan hingga pukul 13.30. Terima kasih.
Mohon maaf Bapak Ibu, ada tambahan informasi dari kami dari Ikatan Odontologi Forensik Indonesia. Kami melemparkan ini ya, siapa yang bersedia ketempatan baik dari fakultas atau dari daerah mana yang bersedia untuk menjadi tempat pelaksanaan the 5th Indonesia Symposium of Forensic Odontology. Jika ada yang bersedia, kami tunggu kepastiannya sampai pukul 3 sore hari ini. Dapat diinformasikan kepada Dr. Nurtami atau ke saya. Baik, terima kasih. Selamat menikmati hidangan makan siang. Biasanya kita emang rolling gitu ya, langsung blast gitu. Kita lobby aja sekarang. Kalau yang kemarin kita Zena. Mana orang-orang dari
Fahmi is the tutor of Kiki. She gives all the files of CBCT to Kiki. Oh yeah, Kiki get graduation. Then Fahmi has a lot of CBCT. That's why Kiki can take the PhD. Fahmi is kecap. Ya.
Yeah, whatever photo, like this one, but sometimes, not sometimes, all How about if we cut like this? This is difficult with
was difficult to determine the margin of the enamel cement, enamel dentin, cement dentin, to root
the
canal.
root canal, yeah.
Otherwise, we have to know the volume of each unit part. Then get some result.
Yeah.
Then we can use that for easy estimation.
Yeah.
That's why it's difficult.
So the way out is how to make it not difficult.
That's why I told my students, you should write a paper. What prevents you to do this kind of
Yeah,
job?
yeah, this is problem,
So what program? What is the program? What are the programs? That's very important.
Yeah, so many answer
Yeah, many,
many participants to answer your problem. Yeah, sensei to answer this problem. So they can
one of them is
continue.
also the sequence of the tomography.
Yeah.
And also the corrected material.
So how about if they cut like line this enamel? It's not possible to do.
Yeah, I hope so.
But one by one it's long.
Yeah, that's why I told my students
Yeah,
to make actual reproducible 3D image
yeah.
using the software.
Yeah, software.
And then measure the volume of each region. Then with age, and then calculate.
Yeah. Papa nggak makan dong? Pakai kepikul. Sensei, how about the two piece of this? Two piece from the last when I.
Yeah, I brought
It is okay for you. It is fit.
Yes.
But the one is not long. It's go to Makassar. You can Toraja you can use.
I could have a chance to go to Toraja this time. Tomorrow I have to leave here to
Jakarta.
Jakarta.